Welcome back to the GCSE Maths Pro YouTube channel. Today we're going to be looking at the third part of Surd rules, which is expanding brackets. Make sure that you've double checked all of these videos that come before this, including simplifying surds and the other surd rules for adding, subtracting and multiplying, because we will be needing these in today's video. So we're going to start off by looking at expanding single brackets, and then later on we'll move on to double brackets. Just as I do with all surd rules questions, I like to relate it to algebra. So in terms of how do we expand in the first place, just use the same method that you would to expand brackets, even if it was to do with algebra or anything else. Expanding just means multiplying. So in this question, we've got expand and simplify root 3 times 7 plus root 15. So before we get into this, we have to really pay attention to what is a surd and what is not a surd, i.e. the 7 here is not a surd. It's a whole number. So the way that I normally expand is I tend to just draw these lines here so I don't forget which ones I've already multiplied and which ones I haven't. So I'm starting off with root 3 times 7. We have got 1 root 3 multiplied by 7. So we're going to multiply the two whole numbers together, which is the 1 and the 7, and the root 3, well, there's no other surd to multiply it by, so that just stays the same. So root 3 times 7 is just 7 root 3. If you think about it, if I've got 1 root 3, and then I times it by 7, I've now got 7 root 3s. And then I'm going to multiply root 3 by root 15. Now we are multiplying two surds together. So if you remember in our previous video, the way that we multiply surds is you just put a single square root symbol and you multiply the two numbers together in that square root. I've put plus because obviously root 3 is a positive, there isn't any negative to tell us otherwise, and you've got plus root 15, which is also a plus. So I'm putting plus in between these two, and then I'm actually just going to multiply 3 and 15, which gives me root 45. Now, this one, again, the coefficient is technically 1 because we had 1 root 3 times 1 root 15, but obviously same with algebra, you're not going to write down 1x. It's not really helpful information. So I've just left it as root 45. So that's the expanding part. We've multiplied everything out. However, we then need to simplify it. In this case, I'm just having a look at, can I simplify either of these two surds? The root 3 I can't simplify because there isn't any square root number that would divide into it. So 7 root 3 is the most simplified I can get. However, if I look at 45, there is a square number that would divide into it, and that is 9. So I'm just going to quickly go through that. If you want to recap simplifying surds, just go back and check out that first video in this series. Obviously, 9 goes into 45. What do I times that by? Well, it's going to be 5. So I've got root 9, root 5. Obviously, I've chosen a square number, so I can literally then go and square root it. That becomes 3, root 5. In our other video with adding and subtracting surds, we know we cannot add together two surds that aren't the same. And what I mean by that is this is root 3 and this is root 5. So we cannot add those two together. We've simplified both of them individually, and that is the most we can do. We can't combine them any further. So your final answer for this question is 7 root 3 plus 3 root 5. Okay, so if you feel like you can have a go at this question yourself, pause the video and then play it when you're ready to see the workings. So expand and simplify root 2 times root 27 plus root 5. This one's a little bit easier because all we have are surds here. We don't have to worry about combining whole numbers and surds. It's all just multiplying two surds together. So first I've got root 2 times root 27, which as we know is just a single square root with 2 times 27, plus root 2 times root 5, which is obviously 2 times 5. Now, you don't have to write out this line of working out. I'm just doing it to really over-explain what is happening. Then we get 2 times 27 as 54, or root 54, plus 2 times 5 is obviously root 10. So we've expanded, and again, now we just want to simplify. Can we simplify either or both of these surds? 54, what square number would go into that? Okay, well, we know that, again, that is a multiple of 9. So I can put root 9, and what do I multiply 9 by? To get 54, it has to be 6. Plus, and then root 10, actually we don't have any square numbers that go into 10, do we? So that one just stays the same. Next, I'm going to square root the 9, which is 3, root 6 plus root 10. So that is as simplified as I can get. So your answer for this question is 3 root 6 plus root 10. Again, every question that we go through, feel free to pause, try it yourself, and then see if you get the same answer. Our third question is expand and simplify 4 root 2 multiplied by root 12 plus 5 root 2. Okay, so we're still doing single brackets. However, now you can see that we are combining whole numbers and surds together. We're just going to focus on how we did it in the other video for multiplying surds. Starting off, we've got 4 root 2 times by root 12. Root 12 technically has a 1 in front, doesn't it? It is one lot of root 12. So I'm going to multiply the whole numbers first. That's the 4 and the 1. Obviously, that's just 4, isn't it? And then I'm going to multiply the surds together under the square root symbol. So I've got 4 lots of root 2 times 12. Again, you might just want to multiply that directly and get 24. That's fine. Same again, the 4 root 2 is positive. There's no other negative symbol to tell us otherwise. And the 5 root 2 is also positive. So I'm going to just put a plus here. We're going to multiply together the whole numbers. 4 times 5 on the outside is 20. And then the surds, we have root 2 and root 2. So 2 times 2. Now I'm obviously going to just go straight forward and multiply those. So 2 times 12 is 24 plus 20 root 4. Okay, so I'm going to see, can I simplify root 24? Are there any square numbers that go into it? Well, I know that 4 goes in. That's pretty straightforward. So I'm going to split it into root 4 and root 6 plus 20. And now if you have a look at this one, we've got root 4. Now we obviously know 4 is a square number. So that's just going to square root into 2. We're going to square root this 4, which will become 2 root 6, plus 20 times 2 is obviously 40. So our last step, I'm going to write it over here. 4 times 2 is 8, and then root 6 is still there, plus 40. Now we can't simplify the root 6 any further, so that is your final answer. Right, so our next question is exactly the same. We're expanding single brackets. However, I've just written it in a format that's slightly different. So you might see that in your exam, the questions are worded slightly differently. You just have to know and identify, do you know what? This is still expanding and simplifying. It's not anything different. But what we have here, they've said we've got root 5 times root 8 plus root 18 can be written in the form a root 10, where a is an integer. All they're saying here is obviously expand it, then simplify it. You should end up with something root 10. An integer just means a whole number, okay? So something root 10, basically. So same as we did before, root 5 times root 8, and then root 5 times root 18. 5 times 8 would be 40, and 5 times 18 is 90. Okay, so we've got root 40 plus root 90. We've expanded. Now we want to simplify. What square number goes into 40? That's obviously going to be 4 and root 10. As we've seen in previous videos, they've told us what surd is going to be left over, so it does kind of give you a hint. I know that when I simplify root 40, it's going to be some square number multiplied by 10. So it gives you a bit of a hint as to where you need to go with finding your square number factor. Same one here, root 9 is a square number that goes into 90, and root 10. So when I simplify that, I get 2 root 10 plus 3 root 10. As we saw with adding surds, you can add them together if they are the same surd. These are both root 10, so I can add these together. So let me just bring this up here. 2 root 10 plus 3 root 10, 5 in total, 5 root 10 in total. That is your final answer. And as you can see, it is in the same format. A root 10, in this case, A is just the 5, isn't it? Okay, so it's exactly the same question, they've just worded it differently. Right, so now we're going to start looking at expanding double brackets. This is also important because this topic of expanding brackets, and in particular expanding double brackets, is what we're going to need when we look at rationalising denominators. So really make sure that this part here makes sense. Right, so expand and simplify. 5 root 2 plus 4 times, that's an imaginary multiply there, 3 root 8 plus 1. Expand it in the same way that you would expand double brackets with algebra. Again, I like to use the lines. You might like to use the grid method. It doesn't matter. However you expand and simplify accurately is the best way to go. So I'm going to start by multiplying 5 root 2 by 3 root 8, which we know we have to multiply the whole numbers together. So 5 times 3, that obviously gives me 15. And then we're going to multiply the surds together. So root 2 times root 8. That all goes in the same square root symbol. I'm just going to directly multiply in this case. So 2 times 8, I know, is 16. Okay, then I'm going to multiply 5 root 2 times 1. Well, anything times by 1 is just itself, isn't it? So that's 5 root 2. Okay, I've already multiplied 5 root 2 by every part of the second bracket. Now I'm going to move on to this 4. So I've got positive 4 times by 3 root 8. Double check, that is a whole number, isn't it? That isn't even a surd. So I've got 4 times 3 root 8, in which case I need to do 4 times 3, because those are the whole numbers. That's 12. And then root 8 just stays the same because there's nothing else I've multiplied it by. There isn't another surd to change it. It's just root 8. And finally, 4 times 1, well, that's pretty straightforward. That's just going to be 4, isn't it? They're both whole numbers. So I've expanded everything, and then now that I've done that, I'm going to simplify. So I've got 15 root 16. Okay, root 16 is a square number, so that's just going to square root. So I've got 15 times by 4 plus 5 root 2. 5 root 2, well, that can't simplify any further, can it? Plus 12 root 8. We know we can simplify root 8 into root 4 root 2. And the plus 4 doesn't simplify, that's just 4 at the end. Okay, so our next line of simplifying, we've got 15 times 4, which gives us 60. We've still got 5 root 2 there. And then the root 4 becomes 2, just square root that to become 2. Root 2 left over plus 4. You might end up with quite a few lines of working out, but I think it's worth it just to make sure we don't make any mistakes. So 60, actually you might want to add the 60 and the 4 at this point. So 60 plus 4 is obviously 64, plus 5 root 2, plus 12 times 2 is 24, root 2. And the last bit is we can actually add these two surds together because they are the same surd. My final answer here, I've got 64, that's a whole number on its own, plus 5 root 2 plus 24 root 2 would be 29 root 2. So that is your final answer. Pause the video, try this one out, and we're going to go through it together now. Expand and simplify root 10 plus 2 root 3 multiplied by, again we've got an imaginary multiply symbol there, 3 root 5 minus root 12. So just be careful with this one, we've now incorporated some negatives as well. So you have to not only think about surds, but also think about when I'm multiplying positives, negatives, and so on, what would my answer be? So I'm starting off with root 10 times 3 root 5. Obviously, that's 1 root 10. So I've got 1 times 3 is 3, and 10 times 5 is root 50 there. Okay, then I've got root 10 times by minus root 12. So a positive times a negative is a negative, and then they're both surds, so I'm just going to do 10 times 12, which is 120. Now I'm moving on to the second term in the first bracket, which is 2 root 3. 2 root 3 times 3 root 5, we've got 2 times 3, because they're both whole numbers, which is 6, and then in the surd, we've got 3 times 5, which is 15. And finally, 2 root 3 times minus root 12. So again, you've got a positive and a negative. So overall, that would be a negative. 2 times 1 is just 2 on the outside, and then inside the square root symbol, 3 times 12 is 36. Right, so we expanded everything. Again, we've ended up with 4 terms, so we know we're not missing anything. Now we're just going to go through the process of simplifying. What square number goes into 50? Well, 25 goes in quite well. Times that by 2. What square number goes into 120? Actually, the largest one is 4. So root 4 times root 30. Okay, plus 6. What square number goes into 15? Actually, nothing, right? There aren't any square numbers that go in. So that's the most simplified you can get. So that stays the same, 6 root 15. And then, again, you get stuck in this trap of going, oh, what square number goes into 36? But actually, just really remember, 36 itself is a square number. So that one I'm just going to directly square root. That becomes 6. Square root the 25, which is 5. Those are all multiplied together. Root 2 is just left over. Square root the 4, which is 2. Root 30, we can't simplify any further. Plus 6 root 15, again, can't simplify that any further. And then minus 2 times 6 is 12. Then we're going to do 3 times 5, which is 15, root 2, minus 2 root 30, plus 6 root 15, minus 12. Okay, if you have a look at this one, that is your final answer, because we cannot simplify anything further, can we? 15 root 2 is the most simplified. 2 root 30 is the most simplified, 6 root 15 is the most simplified, and obviously minus 12 is just there at the end. But we can't add or subtract any of those surds in themselves because none of them are the same. Sometimes your answer might simplify really nicely, and sometimes it will look really messy like this, but that's fine. We know that this is the correct answer. Right, so I've put this question in here just to show you another example of how it might be written differently. We are still expanding double brackets, aren't we? Because when you have a bracket squared, you can write it out fully as the same bracket multiplied by itself. So you might want to write it out like this just so you can visualize it better, but that is still double brackets and we're just multiplying the same bracket to itself. So I'm going to go through in the exact same way. We've got 4 root 20 times 4 root 20, so obviously that's going to give me 16 on the outside, and root 400 on the inside of the square root. 4 root 20 times root 2. Well, 4 on the outside because that's technically a 1, isn't it? 1 root 2. And then root 20 times 2 is root 40. Come down here. Now, because we're multiplying the same bracket together, we kind of know what the next bit's going to be. It's just the other way around, isn't it? So root 2 times 4 root 20 is still 4 root 40. Same exact multiplication, just in a different order. And finally, root 2 times root 2. Luckily, these are all positive, so we don't need to worry about the symbols. That will be root 4. So we've expanded everything. Now let's go through and simplify it. Because we multiplied the same bracket by itself, obviously, a few of these surds are going to be square numbers, aren't they? If you think about it, the first one, we did 20 times 20. Okay, 400, well, that's clearly a square number. So I'm just going to square root that. That becomes 20. So I've got 4 plus 4, which is 8, root 40, and then we'll simplify the root 40 in the next line. And again, at the end, what we did was root 2 times root 2. Okay, well, that's obviously going to make a square number. So square root of 4 is just 2. The next line, 16 times 20, we've got 320. Then, like I said, we can now have a look if we can simplify this 8 root 40. Well, we know that 4 obviously goes into 40 as a square number, times by 10, plus 2 at the end. Next row, well, these are both whole numbers, so I'm going to add those together to make 322. And then we can square root the 4 to make 2 root 10. And so our final answer is 322 plus, obviously here, 8 times 2 is 16, root 10. So you can see that this one did simplify quite nicely. We ended up with 2 terms left over. Okay, our next question is now really going to start relating to rationalizing denominators. As you can see here, we still have 2 brackets. However, they're both the same bracket. One is a plus, one's a minus. Now immediately, even though this isn't literally algebra, I would want you to recognize this format. If you've got 2 brackets that are basically identical except one's plus, one's minus, that is the difference of 2 squares. Now, you're hopefully going to recognize that from algebra. An example would be x plus 4, x minus 4. There are obviously examples with any number, but you can see they're identical brackets except one's plus, one's minus. We're going to expand this and I'll show you what will happen when we do. So 3 times 3 is obviously just 9. Those are just whole numbers. That's pretty straightforward. 3, which is a positive, times by minus root 5. Well, that's technically 1 root 5, isn't it? Or negative 1 root 5. So you've got 3 times 1, which is 3 root 5. That is going to be minus. Positive multiplied by negative is going to be a negative. Then we've got the same thing, however, now they're both positive, aren't they? We've got positive root 5 times positive 3. So we've got plus 3 root 5. And finally, we've then got positive root 5 times negative root 5. So that will be negative root 25. Now we're going to simplify. So the 9 is still there. If you have a look at these, they're both root 5, so we can add them together. However, minus 3 root 5 plus 3 root 5, well, that's just 0, isn't it? They're just going to cancel each other out. So we've effectively got 0 there. And then take away root 25. Well, obviously we did 5 times 5. That's a square number. So that would simplify to 5. And then they're both whole numbers now. 9 minus 5 is just 4. So you can see in this example where we've got identical brackets except one is plus, one's minus, you're always going to simplify it and all of the surds are going to disappear. Okay? They're all going to cancel out or be square rooted. We've been left with just a whole number. That's what's related to the next topic of rationalizing denominators. Okay, exactly the same thing. We've got difference of 2 squares again, just slightly more complex. Both terms are surds, and one of them has a whole number in front. So same exact thing, but I just want to demonstrate what happens when it's a little bit more complex. Root 3 times root 3 is root 9. Root 3 times negative 2 root 6. Okay, so 2 times 1, because it's 1 root 3, isn't it, is 2, and then 3 times 6 in the bracket is 18. Now, this is exactly the same multiplication, except luckily both of them are positive, so it's going to be positive 2 root 18. And then finally, we've got 2 root 6 times root 2 root 6, which is 2 times 2, which is 4, and root 6 times root 6 is root 36. That one's a negative, isn't it? Because we've got positive times a negative. Let's go through and simplify. 9 is a square number, so just square root that to make 3. In the middle, we've got minus 2 root 18 plus 2 root 18. That's just going to cancel out, isn't it? That's just 0, so ignore that. And then we've got take away 4 root 36, and root 36 is another square number, so that would square root to become 6. So we've got 3 take away 4 times 6, which is 24. So our final answer is minus 21. So that is everything for expanding single and double brackets with surds, and a little bit of difference of two squares thrown in there too. The last part of surds as a topic is rationalizing denominators. Make sure you check out those 2 videos, and then you will have covered everything to do with surds. So thanks for watching this video. Don't forget to subscribe, leave any comments down below if you have any questions, and we'll see you in the next video.